This is Sarah Wilkinson, professor at Humber College and the University of Guelph Humber. I would encourage you to visit my previous videos discussing what partial pressure is and how to use the oxyhemoglobin dissociation curve to calculate oxygen content in the blood before you watch this one. This video is going to show you how you can use a given VO2 to calculate the amount of oxygen in the blood, and if you're given cardiac output, how you would calculate VO2max. In a previous video, I showed you the principle of the Fick equation. That is, the volume of oxygen we consume is going to be dependent on two factors. One, the delivery of oxygen, i.e. blood flow, which is cardiac output, or Q, multiplied by the extraction of oxygen from that blood, the VO2 difference. We're going to now start to write the VO2 difference a little differently. That is, it is the content of oxygen in the artery subtracted by the content of oxygen in the vein. So let's do an example. The question is, what is VO2 max when maximal cardiac output is 25 liters per minute? The PO2 in systemic arterial blood is 100, and the PO2 in the venous blood is 15. And they have a body mass of 65 kilograms. In a previous video, I showed you how to use the oxyhemoglobin dissociation curve to figure out how you could find out the content of oxygen in the blood using PO2 and hemoglobin concentration. So at a PO2 of 100, in the arterial blood, we see approximately 19.5 mL of oxygen per 100 mL of blood. And in the venous blood at a PO2 of 15, we see about 5 mL of oxygen per 100 mL of blood. So we're now going to input those numbers into our formula. So the content of oxygen in the arterial blood is 19.5 mL of oxygen per 100 mL of blood. And we're going to subtract how much is in the venous blood. Therefore, the difference between the two is how much ended up in the muscle. We're going to then multiply by cardiac output. Note here how I have cardiac output written in milliliters of blood per minute instead of liters so that I can cancel out units. I'm going to rewrite it here so you can see the VO2 difference. Milliliters of blood cancels out. And if I take 25,000, multiply it by 14.5, and divide by 100, I'm going to get an absolute VO2 value of 3,625. If I'm interested in finding out the relative value, I would divide by body mass, and that would give me a very nice VO2 max of 55.8 mL of oxygen per kilogram per minute.